Welcome. In this lesson, we'll learn how to design an evaluation framework for an AI feature. By the end, you'll be able to build a golden set, write scoring rubrics, and set acceptance thresholds that let you ship AI products with confidence rather than guesswork. AI features behave probabilistically, so the same input can give different outputs, and a model upgrade can quietly break what worked yesterday. A polished demo tells you nothing about reliability. An eval framework is essentially the product spec for quality. It answers three questions: what does good look like, how do we measure it, and what score is good enough to ship? Every eval framework rests on three pillars. First, the golden set, a curated collection of test cases. Second, the scoring rubric, the rules you use to judge each output. Third, acceptance thresholds, the numeric bar a feature must clear before it ships or stays live. Combine these into a repeatable plan and you have a measurement system you can trust. A golden set is your benchmark. Quality beats quantity. 50 to 200 well-chosen cases often beat thousands of random ones. Make it representative of real usage, but deliberately include edge cases, ambiguous, adversarial, empty, and out-of-scope inputs. Tag every case by category, difficulty, and risk so you can analyze by slice. Store it as version data and pull from real, anonymized logs and support tickets, not just the inputs you already know the model handles well. Here's what a single test case looks like as structured data. Each case captures the input, any context the model needs, and an expected output or reference answer. We tag it with category and difficulty for slicing, and crucially we add must-not constraints, hard rules the output can never violate, like exposing another customer's data. Storing cases as JSON or CSV in version control makes evals reproducible. A rubric turns fuzzy quality into a measurable judgment. Use the simplest type that captures what matters. Binary pass-fail is great for correctness-critical tasks. A 1 to 5 scale captures degrees of quality, but you must define each point to reduce subjectivity. Dimensional rubrics score independent axes like accuracy, completeness, tone, and safety, then combine with weights. Always anchor scores with concrete examples, and calibrate by having two people score the same cases until they agree. There are four main scoring methods. Deterministic matching works for structured or classification outputs but is brittle for free text. Programmatic checks reliably enforce hard constraints like JSON schema or required keywords. Human review is the gold standard for subjective and high-stakes quality, but it's slow and expensive. LLMs judge scale subjective scoring cheaply, just validate it against human labels and watch for bias. A common pattern combines programmatic checks for constraints with LLMs judge for quality, audited periodically by humans. Thresholds turn scores into ship or no-ship decisions. Anchor them to product risk and to your baseline, current production or human performance, not an abstract ideal. Define the metric in the bar, for example 90% pass on correctness and 0 safety failures. Separate must-pass gates, like safety and no regressions, from nice-to-have improvements. And remember, small golden sets give noisy estimates, so report confidence ranges rather than treating a single number as truth. Finally, make evals part of your workflow. Run them automatically on every prompt change, model upgrade, and release candidate. Track results on a dashboard and alert on regressions. Continuously grow your golden set by mining real production failures. The concrete deliverable is a one-page eval plan listing the feature, golden set location, rubric, scoring method, thresholds, and a named owner. That document is how you ship AI features responsibly.